Hello, in this video we're going to look at dosing heparin when we're using a protocol. And I've shared with you the entire problem, including the meds, but I do want us to zoom in a bit on this problem and see if we can see some of the details. So let me see if I can change our view. All right. So we have this little X here in the top corner showing us that we're using the cardiology protocol. And as you see, if I scroll down, it says use the cardiology protocol. Your patient weighs 124 pounds. So in the cardiology protocol, I have a couple things that are happening. And the first thing that I have is that they are going to get a bolus, and that is to be at 60 units per kilogram. They are also to get an infusion, which is to be 12 units per kilogram per hour. Both of these do have a maximum, so that's going to be something really important for me to pay attention to as I work through this. Before I even go further, just the rest of this image of the protocol has a venous thromboembolism protocol and a low protocol, but because cardiology is ordered, I'm not going to read the details for those. I have two meds. When I look at the meds, this one is for my bolus, and I know that that's for my bolus because I can see that that is a med that I would need a syringe to put through the rubber stopper, and the bolus is administered with a syringe. My second med here I can see is an IV bag, just looking at the shape of it, and I see the strength here two places, and I want to use the one that is in the reduced format, the 50 units per milliliter, and that is done so that we don't have any errors with all of the zeros with the 1,200, well, I can't even say that, 12,500 and 250. So taking that basic overview down to the actual math involved in this problem. So it says that our patient weighs 124 pounds. First thing I'm going to do is convert that over to kilograms. And the reason why I would do that is because when I had read the protocol was per kilogram. And so I'm going to round that off to tenths because it is in the dot and it's above 10 kilograms. I get 56.4 kilograms. Now, this question asks me for the units and the milliliters for the initial bolus. So I'm going up here and rereading in my protocol. Initial bolus is to be 60 units per kilogram right here with a maximum of 5,000. And my bolus med is 5,000 units per milliliter. I'm going to try to keep track of all that while I scroll. So I found that it was supposed to be 60 units per kilogram. There was a max of 5,000 units, and my med had 5,000 units per milliliter. So I have all the pieces. Let's put them to work. So one is the units. That is one. So one. That means I need to cancel the label of kilograms. So I'll start with the 60 units over a kilogram. 60 units is the amount if the patient weighs 1 kilogram, but they weigh a lot more than that. So I will multiply by the 56.4 kilograms, and that will give me the number of units. So when I do that math on my calculator, I get 3,384 units. And the question here is this amount acceptable? So yes, this is acceptable. It is below the max. So the maximum there is 5,000. I'm well below the maximum. And so I will be able to continue on with my problem. So then step 2 is to figure out these milliliters. So to figure out the milliliters, again, I'm going to go with the dimensional analysis approach. I'm going to use that answer I just had, so 3,384 units and I'm going to use the med that I noted. So that med had 5,000 units per milliliter. So I'm going to have to put the 5,000 in the denominator so that it cancels units. That was per 1 ml. So units cancel. So I do that math on my calculator, and I am going to need to round that off because I can't measure all of the decimals that my calculator gives me. The amount is less than 1, so looking at my calculator, I decide to round this to 0.68 milliliters, 2 decimal places because it's less than 1. So that is all of my work, and I really have 3 answers in this problem. I have the number of units here. I have that this is an okay amount to administer because it is below that maximum based on the protocol, and we read the maximum. And then I've converted that over to milliliters. This is an amount that would be pulled into the syringe and pushed through the IV tubing. Now they ask me to do the units per hour, milliliters per hour, and is it acceptable for the initial infusion? It's pulling up in my protocol. Initial infusion, 12 units per kilogram per hour, max of 1,000. And an infusion is an IV, so this is where I'm going to use my IV bag over here, which is 50 units per milliliter. So again, just going to start by jotting down all this information that I found so that I can keep track of it. So it was to be given at 12 units per kilogram per hour. We found that on the protocol. There was a maximum of 1,000 per hour. That's 1,000 units. And my med had a reduced strength of 50 units per milliliter. And I'd like to have all that stuff in front of me, but I can't just show it all on my screen for the video at the same time. And so I'm writing this down. These are the pieces that I've gathered from the top of the page. So again, we have multiple questions. So the first question I'm going to answer here is the units per hour. So I'll start with the 12 units. And that is for 1 kilogram over the course of an hour. But our patient weighs a lot more, so I'll multiply by their 56.4 kilograms, which we got at the beginning when we converted their weight. That will cancel just the label of kilograms. Everything else will stay. So on my calculator, I get 676.8. There we go. Units per hour. So my next question, is this acceptable? Yes, this is below the max. So 676 is below 1,000, so this is going to be an okay amount to give to the patient. Then I get to move on to the next question, which is the milliliters per hour. So in order to get the milliliters per hour, I'm going to use the answer that I just got, so my 676.8 units per hour, setting this up with dimensional analysis, so putting the hours clearly in the denominator. And I need to cancel the units. So on my IV bag, I had 50 units to 1 milliliter. And so that will cancel the units, convert over to milliliters. So I do that math, and here, because it's an IV, my rounding should be to tenths. So rounding, I get 13.5, and now that label is milliliters per hour. So that's going to be ready to type into an IV pump to deliver that med. So again, I've got 3 answers. I got the units per hour. Because I'm working with the protocol, I have to check if that's acceptable, and it was below the maximum, so that worked out. And then I could go ahead and convert to milliliters to get something that the pump will deliver and is a feasible dose. Now we're told 6 hours later, our client gets an APTT of 41 seconds. So I need to go back to my protocol here, and I need to find that APTT. So here's my APTTs. 41 seconds would be in this range. So it tells me two things to do. Repeat 50% of the initial bolus and increase by 200 units per hour. And then check again in 6 hours. Okay. So repeating 50% of the initial bolus. And so I look down here at what questions I'm asked. And I'm asked to figure out, find the new units and the new milliliters for the bolus. Well, my protocol told me to give 50%. So repeat 50%. Well, I know 50% equals half. So I'm supposed to be giving half as much. Well, half as much of what? Half as much as I gave initially for the bolus. So I'm up here. Here is my bolus, the initial. And I had calculated 3,384 units. So I'm to give half as much. I'm going to take the 3,384 and divide it by 2 to divide it in half. And when I do that, I get 1692 units. But it also wants an answer in milliliters, so I look again up to where I did the math before. My bolus was 0.68 milliliters. And again, I'm going to take that and divide it in half. And so I get that I should administer 0.34 milliliters. And so easier math than starting from the beginning, but I do have to go back and look at my work. So these are the units, which are exactly half of what we gave before. And these are the milliliters, again, exactly half of what we had given them with the initial bolus. Now it says find the units per hour and milliliters per hour for the infusion. So I'm going to go back and look up here at my protocol. It said I'm to increase by 200 units per hour. So I'm going to use an arrow to indicate increase by 200 units per hour. Well, how many units per hour were they getting? So I'm going to go back and look here where I did the units per hour before. They were getting 12 units per kilogram per hour. But this increase is not per kilogram. So that does not have that slash there to make it per kilogram. So I can't add to the 12 because they're not like terms. So since it's not per kilogram, it is not going to be like terms. To the 12 units per kilogram. So where can I add? Well, the label here is units per hour, and this first answer that I got was in units per hour. So those are like terms. So I'm going to take 676.8 units per hour, which was the initial infusion. And to increase it, I will add 200 units per hour. And so they do have matching labels, so that is legitimate to add them. And that gives me 876.8 units per hour, which is an increased dose that has increased by exactly 200 units per hour. So that answers this first part, but they also asked me for milliliters. So I do need to convert that to milliliters. So I'll set up the dimensional analysis. So I have 876.8 units on top, hours on bottom. And I'm going to use that same IV bag that I used before. And that IV bag had 50 units, and this is that reduced fraction off of the IV bag, 50 units to 1 ml. So that'll cancel the units, and I do the math. And again, I'm going to round this to the 1 decimal place, and so I get 17.5 milliliters per hour. And that rounding to tenths is because it is an IV rate, and it is greater than 1. So I have 2 answers here. I have one that is in units per hour, and then using that answer, I was able to convert to milliliters per hour.